Consider the quadratic equation 8 minus 3x squared minus 16x equals 4. And then they're asking you, okay, what are the values of a, b, and c when you write this equation in standard form? Standard form is ax squared plus bx plus c equals 0. So in other words, everything is on one side of the equation or the other. It's also in what's called descending order. X squared is the highest degree exponent, then x is the next highest degree exponent, and then no x. And there's a 0 on the right hand side. So the thing that you have to remember here is that the operator goes with the next term. So it's really minus 3x squared. Do you see that?
Yep.
And then it's minus 16x. Now it's not written, but the 8 is positive, so it's plus 8. Plus 8 equals 4. Okay, so we're close, but we really need a 0 on the right hand side of the equation. So to do that, because this 4 is positive, you're going to subtract 4 from both sides. So that gives you minus 3x squared. Let me not write that, let me write it differently. Minus 3x squared minus 16x plus 4 equals 0. So it's 1, you're rearranging, and 2, you're getting 0 on the right hand side of the equation. Okay, so now what would the values of a, b, and c be in this when it's in this form here?
-3, -16, and 4.
All right, very good. So let me give you one like this to try. Before I guess do that, do you have any questions for me on that?
Nope.
Okay. Yeah, let me give you one here. So let's say I ask you to do something like this, like 5 minus 2x squared plus 12x equals 3. And I want you to write in standard form. So again, that's ax squared plus bx plus c equals 0.
Done.
Sorry, I was muted. Can you tell me what it is in standard form?
5x squared plus -2x plus 12 equals 0.
Okay, so it's very different than what we did in the last problem. So let's start with the first term. So minus 2x squared, that's okay. So right, you're gonna write that minus 2x squared. And then that takes care of the ax squared. Like you got that one done. The bx is plus 12x. Okay. So what is left over in the equation? So this 5 here, is it positive or negative?
Positive.
Positive. So we write plus 5 equals 3. And now this is not yet in standard form. The reason it's not in standard form is there's no 0 on the right hand side. How do you get rid of the 3 on the right hand side?
You subtract 3.
Yes. So that gives you minus 2x squared plus 12x plus 2 equals 0.
Okay.
Okay, so I'm going to give you one to do here on your own. Any questions though on this? And because it's going to be exactly the same.
No.
Just different numbers. All right, let's try another one here. 6 minus 4x squared minus 12x equals 8. So go ahead and write this one in standard form, please.
Done.
All right, what is your final answer?
Negative 4x squared minus 12x plus 2 equals 0.
Okay, small little error there at the end. So plus 6 equals 8. You subtract 8 from both sides.
Mm-hmm.
What is 6 minus 8? It is not 2.
3.
Nope. It's a sign issue. 6 is smaller, or negative 8 is further from 0 than 6. So the answer has to be negative.
Negative 2.
Yeah, negative 2. Okay, very good. All right, let's move on to another question here. Question 2. And this question asks for what's called the discriminant. That's part A. I know it's not shown here, but before we can do that, we have to label A, B, and C. You already know how to do this. So the discriminant is a formula. It's B squared minus 4AC. Okay, now you have all the numbers for it. You have B is minus 17. You have A is 14. You have C is minus 6. Now, very important is when you substitute in, you want to use parentheses. So for example, you could almost treat the formula like this. It's B squared minus 4 times A times C. And the reason you do that is the signs really matter. It's minus 17 squared minus 4 times 14 times minus 6, like that. Is that okay?
Isn't there supposed to be a square root?
It's just the discriminant. The discriminant is just this part, B squared minus 4AC,
Oh, okay. Then
without the square root.
Okay.
So I want you to go to your Desmos Scientific or handheld calculator, and I want you to calculate this for me, please.
Okay. 625.
Perfect. Yeah, very good. All right, so let's do it again for another problem here, and then we'll talk about what the discriminant means. All right, so here is a new problem, and it says, what is the value of the discriminant? Can you tell me the value of A, B, and C in this problem that's written in standard form?
Okay, A is 1, B is 1, C is 4.
Yes. Very good. Okay, so the formula for the discriminant is B squared minus 4 times A times C. Will you calculate that for me, please?
It didn't work.
Okay, so let's try this again here. So you really want to treat it like the variables are in parentheses. Sorry, it's A and then C. So it's parentheses 1 squared minus 4 times 1 times 4. So give that another try.
Okay.
Do you have an answer for me?
Almost. Negative 15.
Yes, negative 15. Very good. Perfect. Okay. Let's try one more here. I'm going to make this one up for you. Let's say it's x squared minus 4x plus 4. Yeah, that'll work here. What's the value of A, B, and C in this problem?
1, negative 4, and 4.
Very good. So the discriminant is B squared minus 4AC. And again, you just want to substitute your numbers in parentheses. Okay, so go ahead and calculate that for me.
Zero?
Yes. Very good. Okay, so there are 3 possibilities when it comes to discriminant, and this would be worth writing down. The first is that the discriminant is greater than 0. It's some sort of a positive number. And in this case, there are 2 real solutions. The second is when the discriminant equals 0. Okay, so it's literally 0. This means there is 1 repeated real solution. And then the third is when the discriminant is less than 0. So it's a negative number. that means there is no real solution. So once you get the value of your discriminant, we did 3 different examples. You would want to have like this table available either from writing it down from me or looking in your notes, or somehow getting this and being able to draw the correct conclusion.
Okay.
All right, so let's go a bit further here, and let's actually try to use the quadratic formula here. So you actually were able to do these ones correct on the homework assignment, which is great to see. We'll just review for that. So let me snip that question in. All right, so we want to use the quadratic formula. You have to identify A, B, and C correctly. And then the full quadratic formula, you're asking about this earlier. Yeah, it does have a square root. It's the square root of B squared minus 4AC over 2A. Like that.
Okay.
So the part we've been doing is been over here in the discriminant under the square root. So some students like to do that part first, but I would like you to substitute all the numbers. And again, like the formula really should be written like this, where everything is in parentheses, because you really do want to substitute in parentheses like that. So it's minus parentheses 4 plus or minus the square root parentheses 4 squared minus 4 times 2 times -1 all over 2 times 2.
Okay.
So now just comes the issue of being able to simplify. So could you do the part under the square root for us? Not with the square root, just the numbers under the square root.
$24.
So the square root of 24,
Mm-hmm.
like that.
Yep.
Okay, over 4. All right. Now this is correct. This is completely correct. Unfortunately, there's a bit more to do with the square root. Do you recall how to reduce that?
No, I don't think I remember.
Yeah, and so I'm going to hold off on showing you that, because it's really important here that we get like this other stuff just down really well, and then we'll talk about how to do the square root here. So let me give you another problem here to look at. So we want to solve this equation using the quadratic formula. So do you have the quadratic formula written down?
Yep.
All right, could you tell me it, please?
Okay. Negative B plus or minus square root B squared minus 4 A and C.
Anything else?
Of O on top of 2A.
Good, very good. I'm glad you know that or have that written down. So in your problem here, A is 3, B is -2, and C is 7. Okay, so I want you to figure out the determinant here, this part under the square root, please.
$65.
Try again. So it should be -2 squared, right?
Oh.
-4 times 3 times 7. That doesn't look right either.
Is it 60?
Sorry, I'm looking at what I
Oh.
wrote and it still doesn't look right. B squared minus 4AC. That's not right. Yeah, that's right. 3 minus 2 and 7. B squared minus 4AC. A is 3, B is minus 2, C is 7. Okay. 4 minus 84, it should be minus 80.
Yep, that's what I asked.
Okay. I heard something different. All right. So let's go back and look at our table. The discriminant in your problem was minus 80. Which of these three possibilities is it?
3.
So that means there's no real solution. Okay, so let's talk a little bit, use our last 5 minutes here to talk about reducing roots. This is one of those skills that you need for solving with the quadratic formula. So we looked at a problem that had the square root of 24 in it. And you need to remember the prime numbers 2, 3, 5, 7, and so on. Okay. All right, so does 2 go into 24?
Yes.
2 and 12. And then you try 2 again. Does 2 go into 12?
Yes.
2 and 6. And then does 2 go into 6? Yeah, 2 and 3. So you circle the pairs.
Okay.
So for each pair, you can bring a number out. So in this case, you can bring a 2 out. But what's left over? What's still on the inside of the square root? Everything else that you didn't bring out. So there's a 2 times a 3 inside. So that's 2 square root 6. Does that make sense?
Yep.
All right, let's look at another one here. Let's look at the square root of 80. So you start with 2. You always start with 2. 2 works in a lot of them because it's even. 2 times what number gets you back to 80? What's half of 80? Half of 80.
Oh, half of 80, 40.
40. Yep. And then you try 2 again. You're like, well, if it worked once, maybe it'll work again.
20.
20. And you try 2 again. Does 2 go into 20?
Yep. 10 times.
10. And then there's a 2 and a 5. So you stop when you have prime numbers on the outside on these leaves. It's usually going to be in this list up here, prime numbers. So for each pair, you circle pairs. You've got 2 pairs here. For each pair, you bring a 2 out, or whatever that number is, you bring a 2 out. Does that make sense? Like if they're paired up, you bring one out. So you have a 2 times 2 on the outside. Square root of what's left over.
Five.
Yeah, so it's 4 square root 5 because the 2's multiply.
Four over 5. Square root of 5.
Okay, let's try one more here. Let's try the square root of 60. So does 2 go into 60?
Yes.
Okay, so 2 and what number goes here to the right of it?
30.
30. Okay, and then try again. What does 2 go into 30?
Yes.
Yes, because it's even. 2 times what number gets you back to 30?
9.
15. right? Half of 30. You're probably 15 or close to it. You're gonna double your age, gets you to 30. That's a scary thought. Does 2 go into 15?
No,
Nope. But 3 does. 3 times what number gets you back to 15?
5.
5. Do you have any pairs of numbers on the outside here? Any pairs?
Just the 2 2s.
So you can bring a 2 out. And what's left over? What numbers remain on the inside?
3 times 5.
3 times 5. So it's 2 square root 15. Does that seem okay?
Yeah.
All right, let's have you try this one to close out here. You try the square root of 40 for us.
2 4. 220.
Okay.
210.
Okay.
2 5.
Okay. What do you do from here?
You connect the pairs, which is you bring 2 out
Good.
and then square root, then 2.2 times 5.
2 times 5, which is 10. So 2 square root 10. Hey, good job today. Good energy. Felt like you were definitely engaged the whole time. We'll pick up here on Wednesday with either, new topic or related topic, but thanks for letting me help you, and I'll see you next time.
Yeah, Matt.
All right. Have a great night. Bye now.
You too. Bye.